Okay. Now today we look at this core question, which I guess we did not discuss last week. But what exactly is a program? Is there a definition to a program? That's what we are going to learn today. So yes, there is a definition to a program. Program is nothing but sequence of symbols which specify any computation. So जो भी computation मुझे करना है, उसको specify करने के लिए जो भी sequence of symbols are used, they are called as program. Okay, a programming language is then what? It is a set of rules that specify which sequences of symbols constitute a program and what computation the program describes. So there are two things that the programming language does. One thing that a programming language do is it separates out the sequence of symbols, okay, that constitute a program from everything else. Okay, so it actually lays down certain rules that will guide us to understand what is a program and what is not a program. So whatever sequence of symbols that we write, are they program, will be decided by the rules of the programming language. If we follow, while organizing the symbols, the rule of programming language, then whatever we have written will always be a correct program for that programming language. ये आपको याद रखना है. When somebody asks you or somebody questions you, what exactly you do when you say you are programming? So you should say that programming means I'm writing certain symbols, sequence of symbols, and those sequence of symbols are doing what? They are doing certain computation. So writing sequence of symbols to do computation is writing a program, and a programming language is set of rules. So anything that we refer to as programming language is nothing but it's a collection of व्याकरण, that what we call in natural language. सेट ऑफ रूल्स म्हणजे व्याकरणाचे नियम असतात ना आपल्याकडे, मराठीत असतात, हिंदीत असतात. सो ऑल यू इन इंग्लिश ऑल्सो देर आर सर्टन रूल्स ऑफ ग्रामर. So programming language is basically that set of rules, that set of grammar which decides which symbols will constitute, which sequence of symbols will constitute a program, which will form a program. Then it will also have, so these are not rules are not limited to identifying what constitutes a program, but it also identifies what computations that program will do. So the programming language should also be able to describe the computation that program has. इसी चीज को दूसरे सिंपल टर्म्स में आपको बताया गया है जब आप सीख या कोई दूसरा प्रोग्रामिंग लैंग्वेज एज अ फर्स्ट प्रोग्रामिंग लैंग्वेज सीखते हो. दे कॉल इट एज syntax. So these words are very common: syntax and semantics. So semantics refers to the meaning and syntax refers to the organization of the code, the content of the code, the organization of symbols that constitute the program. एक प्रोग्रामिंग लैंग्वेज के तरह के रूल्स के साथ मैच होता है या नहीं, सिंटैक्स डिसाइड करेगा. सिमेंटिक्स डिसाइड करेगा कि कौन सा कंप्यूटेशन वो प्रोग्राम कैरी आउट करेगा. व्हाट कंप्यूटेशन डज द प्रोग्राम डिस्क्राइब्स, और इफ आई एग्जीक्यूट दोज स्टेप्स what it is going to compute. That is what the semantics would decide. So semantic concentrates on the meaning. So meaning का मतलब क्या है? What computation you want to do, that is the meaning. And syntax का मतलब क्या है? Do you match the rules of the given programming language or not? Okay. As this end note you see over here on this slide, surprisingly the word computer is missing from both the definitions. So program can be a sequence of any symbols. ते हातवारे असू शकतात, ते नॅचरल लँग्वेज असू शकते, ती प्रोग्रामिंग लँग्वेज असू शकते, ती कम्प्युटर प्रोग्रामिंग लँग्वेज पण असू शकते. पण कुठेही कम्प्युटरचा वर्ड नाहीये या डेफिनेशन मध्ये, हे लक्षात ठेवा. सो द प्रोग्राम अँड प्रोग्रामिंग लँग्वेज दे refer to any generic language using which you want to convey an idea, and that idea is about a computation. Okay, so it can be a mathematical set of formulas, it can be constituent using some sort of a flow chart, it can be in the form of an algorithm, or it can be in the form of any actual program code in some specific programming language. तो प्रोग्रामिंग लैंग्वेज और प्रोग्राम को एग्जिस्ट करने के लिए ज़रूरी नहीं है कि आपको कंप्यूटर की आवश्यकता है. यू डू नॉट रिक्वायर दैट पर्टिकुलर डिवाइस. अल्टीमेटली वो कंप्यूटेशन अगर आपको एफिशिएंटली इवैल्यूएट करके लेना है, you want to actually execute it, there you require a device called as a computer. So please understand that fact. Okay, well, this is about what I missed last lecture. Next thing, how did high level programming languages got developed? Were high level programming language the languages that were developed first? No, everything initially was binary and close to electrical circuits. So the assembly language, or the machine language as they call it as, that got developed first. So we used to talk to these devices, physical hardware devices, in terms of some sort of codes or some sort of instruction sets. And later on, these instruction sets and codes got higher and higher level abstraction added to them in order to make them more understandable to us human beings who are going to write the program for the machine or the hardware collection, right? So the development of programming languages started from, as far as the computer programming languages are concerned, they started from initially people understanding or people using the assembly or the machine level code, later on getting graduated into more and more abstract representations to know about the middle level programming languages, and like assembly and other, and then we reached at a high level programming language. So जो development of high level programming languages है वो sudden नहीं है, वो gradual है, and we are actually moving away from the hardware in terms of our representations. Okay, so please understand the early computers were like calculators which had specific set of subroutines wired in them. तो ये पहले से ही वायर्ड इन होते थे हार्डवेयर में, और वो हार्डवेयर उतनी ही चीजें कर पाता था. So I may consider that I had a AND gate that will only do ANDing of two sets of uh, analog signals which were given to it at its input gate. Okay, so I had those kind of things initially. Okay, then there was a development of a Van Neumann architecture of a computer, wherein we could store certain set of computing instructions. Stored program computing concept means what? We can store some set of instructions inside that particular computer's memory. These instructions could be fetched and executed. So we had a concept of, if we want to execute different set of instructions, we will replace the set of instructions from memory with new instructions. These new instructions may compute differently than my earlier instructions. तो ये जो higher level of abstraction add हुआ है वो add हुआ है because of this von Neumann architecture of computer. We are not going to learn about the computer architecture in the subject, but we need to understand that initially it was all collection of electrical hardware components. Later on, they abstracted them, they separated into control unit, memory unit, and secondary devices. Okay, as we segregated these things, we could now store the set of instructions in the memory, which could be on the hop while you are executing the code, taken into the control unit and executed over there using the arithmetic logic unit. So these are components of your computer's central processing unit, CPU, which you might have studied in some lower classes which introduce you to computation or a computing device. अगर नहीं तो imagine करो, I have a black box called as computer. When I go inside it, there are certain distinct parts of it. One part I may refer to it as a memory. The other I might refer it to as a central processing unit. Inside the central processing unit, I may have a control unit which controls what instructions to execute over the processor that processes the instructions. Okay, and there is a unit called as arithmetic logic unit, which does the processing of some arithmetic operations and logical operations. So whatever we compute at in the high level programming languages is at the machine level is translated into simple binary instructions that do very primitive operations like adding, subtracting, multiplication, binary at the binary number level, swapping values, changing values from one to the other. So these all instructions, they are part of the instruction set that my processor or computer processor understands. ओके, सो मेरे मेमोरी में क्या स्टोर रहता है, मेरा प्रोसीजर स्टोर रहता है. स्टोर्ड प्रोसीजर कंप्यूटिंग में मेमोरी में इंस्ट्रक्शन स्टोर्ड रहते हैं. और जैसे जैसे कंप्यूटिंग प्रोग्रामिंग लैंग्वेजेस डेवलप होते गए, ये जो इंस्ट्रक्शंस है ये एब्स्ट्रैक्ट होते गए फ्रॉम द हार्डवेयर. इनिशियली these instructions were merely binary codes. 0-1 फॉर्म में ये इंस्ट्रक्शन मेमोरी में स्टोर होते थे. मेरा कंट्रोल यूनिट एक एक इंस्ट्रक्शन को फिच करता था, उसको प्रोसेसर में एग्जीक्यूट करवाता था थ्रू द हेल्प ऑफ अरिथमेटिक लॉजिक यूनिट. Later on, as they developed high level programming languages where the abstract representation of the machine codes was done, you required you required programs called as assemblers, you required programs called as the compilers, the interpreters, in order to convert these high level representation जो हमको आपको समझ में आती है बट हार्डवेयर को समझ में नहीं आती, उनको कन्वर्ट करने के लिए हार्डवेयर को समझे ऐसे लैंग्वेज में we started talking about these softwares which are referred to as assemblers for writing assembly code, interpreters and compilers for translating code written in one programming language to the other programming language. Especially when we use the compilers, we try to convert a high level programming language code into its equivalent low level programming language code or a assembly code. Okay, so that is about the development of high level programming language, and it was not done in one go. Okay, we see today explosion of many high level programming languages, but they were not developed early in the development of a computing device. Okay, computing device early in its existence had only instructions, set of instructions limited into processor unit that can be executed just like calculators. Okay, later on it got its capabilities that we see today. Okay, now the next thing that we were supposed to understand is how different programming languages got developed. So there are many there are many programming languages, as we see here in this this particular slide as well. And we had also seen that word cloud where we saw that there was very much large set of programming language. यहाँ तो बहुत कम programming languages इस slide में दिख रहे हैं आपको. And see the period 1940 से 2010, 2015, 2019 तक का पीरियड यहाँ पे लिखा है. इसके बाद भी बहुत सारे प्रोग्रामिंग लैंग्वेजेस डेवलप हो चुके हैं. इसमें से कितने प्रोग्रामिंग लैंग्वेज हमको पता है as such that we have discussed within 2-3 days. Within 2-3 days we had discussed about C, C++, SQL, Prolog. We use this word Lisp. अगर आपको याद है तो पिछले लेक्चर में we know about Python, we know about Perl, we know about Java. See, some of you might have heard about C#. I guess this much at least we know of these programming languages. We also know we also talked about what do you mean by PHP. PHP is a scripting language करके मैंने बताया था. ऐसे ही एक JavaScript नाम का एक scripting language है. So there are a lot of languages. So इतने सारे language at least हमको at least उनके नाम पता है. But there are still many languages that you see over here, and they have variety in their existence. ये variety क्यों है ये हम लोग सीखेंगे कल के लेक्चर में. Today we concentrate on how do we segregate these languages into categories, and that we did, I guess, last lecture. If you were there, we talked about two distinct classes of programming languages. that are referred to as different programming paradigms, different styles of programming. One is declarative style of programming, the other one is imperative style of programming. Under declarative style of programming, we looked at there were different sub styles, you may say, you may refer to. Okay, one is functional, the other one is data flow, logic constraint based, or the template based. So ये template based नहीं था हमारे slide में, but all the other things we talked about. Imperative, we talked about von Neumann programming languages, which are also, I told you, called as structured programming languages. There are scripting languages and object oriented languages. Okay, object oriented languages differ from von Neumann languages in the way they organize the data. We talked in detail about all these things in the previous lecture. If any one of you have missed the lecture and he wants a repetition of that lecture, I've actually made the YouTube video of that lecture recording, so you can visit there and get advantage of it. थोड़ा फिर से सुनोगे तो आपको फिर से वो understanding हो जाएगा, right? Now we talk more in more details about these paradigms and we try to understand how they compare with each other. So imperative paradigm does what? It actually focuses on how to execute and defines a control flow as statements that can change program state. तो ये important criteria है to distinguish between an imperative and declarative paradigm. प्रोग्राम स्टेट का कंसेप्ट जो हमने सीखा वो स्लाइड में, जो पीछे वाला स्लाइड मैंने बताया था, उस स्लाइड में हमने वही सीखा कि व्हाट डू यू मीन बाय प्रोग्राम स्टेट. प्रोग्राम स्टेट मींस हम कैसे डिफाइन करते हैं प्रोग्राम का स्टेट. प्रोग्राम स्टेट इज डिफाइंड बेस्ड ऑन द वैल्यूज द वेरिएबल्स इन द प्रोग्राम हैज. एज द प्रोग्राम स्टेप्स एग्जीक्यूट, अगर वेरिएबल्स के वैल्यूज चेंज होते हैं तो मेरा प्रोग्राम का स्टेट चेंज होता है, ये मैं अज्यूम करता हूँ. तो इंपरेटिव प्रोग्राम में यानी सी लाइक प्रोग्राम में या जावा लाइक प्रोग्राम में होता क्या है, they actually try to manipulate the variables by assigning newer and newer values as we compute the results. अल्टीमेटली कंप्यूटेशन किस लिए करते हो, आपको कोई रिजल्ट ऑब्टेन करने होते हैं, यू वांट टू ऑब्टेन सम कंप्यूटेशन रिजल्ट्स. Okay, so while converting inputs into the outputs, what we do is we manipulate the variable values that are stored in between. तो ये जो वेरिएबल का मैनिपुलेशन होता है वो जनरली किससे होता है, असाइनमेंट स्टेटमेंट से होता है. या मैं कोई फंक्शन को कॉल करता हूँ एंड दैट फंक्शन रिटर्न सर्टेन वैल्यू व्हिच इज असाइन्ड टू अ वेरिएबल. तो असाइनमेंट स्टेटमेंट जो मेरे प्रोग्रामिंग लैंग्वेज में जनरली बहुत importantly use hota hai in many of the imperative programming language. That is the reason why these languages are generally referred to as the languages that change the program state. तो ऐसे असाइनमेंट स्टेटमेंट डिक्लेरेटिव पैराडाइम में आपको बहुत कम दिखेंगे. Okay, they will be very seldomly seen in the pure declarative programming languages. You will often miss them in declarative programming languages because we are tuned to do programming based on assignment to a variable and use the variable for doing computations. Okay, so that's the main distinction between imperative paradigm and declarative paradigm. So declarative paradigm, we organize the we do not organize rather on the flow or execution flow of the code. Rather we define the program logic, but we do not give the detailed control flow. Programming logic जो है वो define किया जाता है, somehow that programming logic is in represented, but they do not represent in declarative programming paradigm how to compute things. Okay, and that's the important distinction between an imperative paradigm and declarative paradigm. Now nowadays people also think of concurrency as a separate paradigm, but if you will find books which say that it is nothing but an extension of an imperative paradigm. ओके, सो इसीलिए ये थोड़ा अलग लिखा है और उसको अल्टरनेटिव पैराडाइम के तौर पर रिप्रेजेंट किया है. कॉन्करेंसी यानी पैरेलल प्रोसेसिंग. मेरे पास अगर एक के जगह पे दो कोर है, यू मस्ट हैव हर्ड दैट नाउअडेज योर सिस्टम्स, जो कंप्यूटर्स आप बाय करते हो वो मल्टी कोर होते हैं, 8 कोर, 16 कोर, 4 कोर. तो वो जो CORE कोर है दैट इज कंप्यूटिंग कोर. सो आई मे एक्चुअली डू पैरेलल प्रोसेसिंग ऑफ सेम जॉब ऑन डिफरेंट कोर्स, क्योंकि मेरे पास दो कंप्यूटेशन यूनिट्स है. तो एक कंप्यूटेशन कंप्लीट करने के लिए मैं उसको डिवाइड पार्ट्स में करके अलग अलग